Welcome to this short session about telemetry in Java using OpenTelemetry. My name is GianMaria Romanato. My colleague here is Renato Bertacco. We are not affiliated with the project, just happy users who would like to share our positive experience. We both work for a company based in Italy. Its name is SIAV. It's written here, and we provide products and services to organizations who want to digitalize their processes, especially in the domain of document management. So let's get started. So first, some comments about what observability is. So I guess we all know what monitoring is, any technique or tool that helps us realize that there's been a problem in our application. So we usually use monitoring in production, and it's very valuable. We get a warning when the application crashes or it gets slower and slower. But then once we know that the problem is there, how do we figure out what is the root cause of the problem? No? So where is telemetry and observability kicks in, and it's very important. Observability is a term that we borrow from control theory. In control theory, a system is said to be observable if you can understand its internal state from its outputs. So in an application or in a Java enterprise application, outputs could be logs, input-output requests, other stuff. And if that is enough to understand the internal state of the application, then we can maybe identify precisely the root cause and fix the problem. Observability is usually built on three pillars. Logs. Everyone here, I'm sure, knows logs and the importance of having good logs with proper granularity to diagnose issues. And then we have traces and metrics. Today we will just talk about traces, but OpenTelemetry can also deal with metrics. It won't be discussed today for timing reasons. So this is super useful in production, we will see. But if you if you have the good practice, for example, of performing performance tests of your application in your development environment, then you will find out that good traces are very helpful there as well. They allow you to identify bottlenecks, areas of improvement. In the past, we used to sometimes use profilers to diagnose certain issues by using OpenTelemetry. We don't need this anymore, and in our automation servers based on Jenkins, we now have an option to switch on OpenTelemetry when we deploy our application to Kubernetes in the QA or test environment, and then we can collect the data that is very valuable for understanding where our performance issues are, for example, and of course in production for problem determination. So, two words about OpenTelemetry, which is an open source project hosted at GitHub, developed under the umbrella of the Cloud Native Computing Foundation. It's usually shortened to OTEL. And as I said, it allows you to easily enable trace and trace propagation in your application without requiring Java changes. And that's because you can, of course, add more traces if you want, more telemetry data. We will maybe see this later. But a very good idea, smart idea behind OpenTelemetry is that every application we'll build today is built on top of a lot of open source. So there might be a web container, there might be a framework like Spring, or if we have a microservice application in which one microservice is calling another one, maybe we are using Apache HTTP client or OK HTTP to perform the call. We possibly use Hibernate or Eclipse Link as our GPA provider, which basically corresponds to the persistence tier of our application. So yesterday, I saw a couple of presentations in which people mentioned that probably if we take one of today's applications, just 10 to 20% of the code we write is ours. The remaining is all provided by third-party components. So if we had the possibility to have these third-party components provide automatically telemetry data, then 90%, up to 90% of our application would automatically provide telemetry data. And this is what OpenTelemetry does. You might be familiar with the concept of agents at the JVM level. So on the command line of the JDK, you can specify a JVM agent which can manipulate your code, your bytecode, when it's loaded in memory by the Java virtual machine. This is called instrumentation. So OpenTelemetry provides you with an agent that on the fly modifies the binaries of the third-party components you're using and injects additional behavior in there so that these libraries start producing automatically telemetry data for you. It's a very smart idea, and in their GitHub repository, there is one repository that is dedicated specifically to instrumentation, and there you can see there is a long list of modules for the different open source libraries on the market. So how does OpenTelemetry work? So as I said, we will see shortly, you enable instrumentation of your third-party components by specifying the agent on the command line. And this somehow augments your application. Within the agent, there is also an entity which is called the exporter. So the libraries that have been modified by OpenTelemetry will start producing telemetry data. This data will be sent to the exporter, which is now part of your application, and the exporter will forward the data to the OpenTelemetry collector. The OpenTelemetry collector is a separate application, and the OpenTelemetry collector at the end is there to forward the data to the real telemetry backend you will be using. There are several on the markets. The very popular ones are OpenZipkin. I believe it was created by Twitter. And there is also Jaeger, which I believe was created by Uber. Right? Thank you. So what's the purpose of the collector? Well, the collector is valuable because it could group together telemetry data and reduce the number of pushes to the telemetry backend. It could filter, keep the data, and perform retries if the telemetry backend is not immediately there. It's especially useful in a large application. So rather, if you have many microservices, rather than having all of them push all the data to the telemetry backend, you can push the data to the collector. You can scale the collector and deal with large amount of data being produced by your application. But in development, sorry, too many clicks. In development, or on the developer workstation, you can skip the collector and tell the OpenTelemetry exporter to publish data directly to the telemetry backend. In the demo that my colleague will present later, we are doing exactly this. We are running Zipkin locally. Zipkin is a very simple application. It ships as a Uber jar, so you just java-jar Zipkin, and Zipkin comes up. So it's very easy to connect your application to Zipkin and immediately see what's happening. So how do you enable tracing in OpenTelemetry without a collector? It's super simple. You specify the Java agent on the command line, and then you define a number of system properties. Hotel traces exporter to choose the format, hotel exporter Zipkin endpoint, because in this case we are using Zipkin. There are different set of properties for different telemetry backends and formats. And then you go on with your own command line parameters for your Java application. So if you are deploying to Kubernetes, you most likely have all those parameters in the YAML file. And it's super easy to enable telemetry without even touching your application by just doing that. Of course, you need to have the Java agent somewhere, either in your Docker image or on a volume mounted to your application. But other than that, no changes in your code. And then what happens if the application is a microservices application? And in that case, wouldn't it be great if this telemetry data was not only limited to what's happening within one single microservice, but was able to correlate invocations that happen between different microservices? So for example, my client is calling a functionality on microservice 1, but microservice 1, to be able to serve, to reply to that request, needs to call a functionality on microservice 2. Each of them will be pushing their respective data to the telemetry backend, but wouldn't it be great if I could see this as a whole, like end-to-end, involving all the microservices together? So there is an approach for this, which is called trace propagation. And trace propagation is usually based on HTTP headers. So when your first service receives a request, it creates a unique identifier for the trace it's going to perform, and uses this in all the telemetry data that it's pushing to the telemetry backend. If service 1 is calling service 2, service 1 should forward the trace identifier in the call to service 2 as an HTTP header, and service 2 should use this header and use the same trace ID in the telemetry information it produces. And this way, in the telemetry backend, you will be able to see all the steps together as if it was a single invocation on a single application. And of course, you can do this. You can write your call to HTTP, your HTTP call to service 2 to forward a header, but that would need changes to your application. If you enable OpenTelemetry, OpenTelemetry will manipulate your web container, maybe Tomcat, to deal with the fact that the HTTP request might contain a header. We'd also keep this header somewhere, and also modify maybe Apache HTTP client or OK HTTP to forward the header in the subsequent HTTP call. So completely transparent to you. Headers, if present in the request, are recognized and forwarded. There are a couple of standards for these headers. Again, Jaeger has its own, Zipkins has its own. There is a specification from the W3C consortium. OpenTelemetry supports all of them. You just need to configure which format you want to use. So how do you do this? Very simple as before. You just add a few more command line parameters. One of them is the most significant one, is the Java agent extensions, which is kind of an OpenTelemetry plugin, because trace propagation is an optional feature that it's not included in the basic Java agent. And then two more, one to enable trace propagation, and another one to choose the format for the headers. B3 multi is one of the formats supported by OpenZipkin. And with this, I think I'm done. My colleague Renato will now give you a short demonstration. His code is published on GitHub here.
OK. This was the theory. Now let's try to see OpenTelemetry in action. Sorry. What I try to do is modeling a simple application for the demo. The application is a bike shop for renting a bicycle. So it is based on 3 microservices. One contains the bike catalog, another one manages the client address book, and the third one is a service that acts as a bridge that allows you to rent a bike. Basically, client service, microservice, and bike microservices have 2 databases. I used H2 in-memory database. And the third one is just a bridge, so there is no database. And the data model is very simple for both of the microservices. So here you can see that there are just a table with the clients, and with the name, identity card, email, and so on. And for bike service, we have just a model, a size, rate, and if the bike is rented, the ID of the client that rented the bike. And the rental microservices, As I said, it's just a bridge. So when you start a rental, where is the first microservices, start a rental, you can put the back ID, the client ID, and act as a bridge. So is merge join the two table and set the.
That's on the list.
Yes, on the list, sorry. Just set the rented by in the bike table. And if you run the list services, list rentals, it has as a bridge, so query the bike microservices, query the client microservices, and join the table and produce the result. Okay, let's go to the code. Just to give you some detail about how trivial is this application. This is just for demo purpose. So if we go to bike microservices, we can see that there is just a REST service. We used Spring Boot. Okay, so there is just a REST controller, a business service, data model. We model it with, we use Hibernate, so it is just an entity. And very similar to this one is the client application, same structure, REST controller, repository, Spring Boot, we use Spring Boot data, so it is just a Spring repository for query our data. And very similar to the previous one. And the rental app, here we don't have any database. We have just a REST service, with which one that's list the bike, we list what is available, start a rental, stop a rental, and so on. And it uses two frame clients. This one for bike microservices, and another one for client microservices for submit the request to the other two microservices. Here there is no dependencies from OpenTelemetry at all. Okay, just it is what you see. Okay, let's boot. Just in the demo. If you want to try by yourself the demo, it is very easy. I try to document it. I create some script for making your life easier. Build script. Let's download ZipKin, download OpenTelemetry, and build the application for you, and run script that run ZipKin and our microservices.
F12.
If, as you can see, it is exactly what GianMaria said before. The first line is for running ZipKin, and the other is for running our application, our microservices with the Java agent, OpenTelemetry. Ok, now
Ho riavviato, quindi devi fare. Ho riavviato.
Ok. It is already.
No, devi avviarlo.
Devo?
Sì, perché ho riavviato la macchina.
Ok, so run our application. Now, ZipKin is starting. After our Spring application starting, and in some minutes, some seconds, actually. Okay, the demo is ready. So we can go to OpenTelemetry. Report, sorry, ZipKin.
9411.
Okay, this is ZipKin. We can see what has tracked at the boot of our application. Here we can see that something happened a few seconds ago. We have some call to our microservices. This, for example, is just Hibernate, that's drop table, and
Creates
that's
the
all.
database. Yeah.
Okay.
Yeah, the demo is creating the database from scratch in memory at every run, and it's also populating the tables with some test data. So when it starts, you immediately find telemetry information for these operations.
Okay. So after we create the data, so basically, as you can see, there is a client service that is called this repository, save all, and start to insert our client in our database. Okay. This is an insert. You can see that it is inserts in the table, and you can see how long take the query.
The query. So this is called a trace, and every line is called a span. Okay. So
aren't the blue things the spans, not the lines?
Sorry?
Aren't the blue things the spans?
Yeah. Well,
spans for one line.
It's kind of like a stack trace, no? So the topmost is all the time required, and then you have the slices of individual time of each of them. As far as I understand, one of these lines which corresponds to one of the steps in a trace is a span.
Yes, exactly. So if we go back, you can see how many span take the request. Exactly. In this case, 12. We have 12 span. This one, it is much more. Okay, and here you can have a breakdown of each span. Okay, where the time that each span take and what the span does. Okay.
Then we can see.
Now we can see if I try to rent a car, a bike. So just some request. Okay. Now I'm telling to rent the bike 1, and it is rented by client 1, bike 3 to the client 3, and okay, and so on. Now go back to Zipkin, run another query, ordering by start time, and we can see that now the start rental service is called, and we have a breakdown. Now you can see that it is called the start rental with a put request, and here you have the parameter, so the URL that is called, and the rental service called another microservices. And this microservice is the bike microservices. Again, you have the parameters, so bike 3 is rented by client 3. And you can see that the request header has been propagated. So in this way, Zipkin is able to see correlate the microservices call, and you have exactly, it is easy to understand exactly what your application is doing. And again, after you can go on the bike microservices and see what the microservices does. In this case, find, query the database using the repository, and you can see here the query and so on. On the other hand, again, this is a bridge, as I said, so it is also called the client service, and query the client service and select and do something. If we show the list of rental, again, okay, so I call a microservices that provide for us what are the bike rental and who the client that rent the bike.
So there is a service here that shows which bikes are rented. No? So it's first calling the bike rental, where in the column of the table of the bike, we have the ID of the client who rented the bike, and then it's calling the other microservice with that ID to get the contact information for the client. So it's not the best implementation, because if we have 100 bikes rented, we are making 100 calls to the client microservice. But for the purpose of showing how OpenTelemetry can help, it's very useful, because all the green lines corresponds to the calls to the other microservice. So we see everything together in a single kind of stack trace, in a single trace, and what's happening in the client microservice, which is the green one, I think, and the bike microservice, which is the bluish.
The color, yes, is very similar.
Yeah, the other one. Okay.
Okay, so again, you can see that the list rented service is act as a bridge, call the bike microservices, asking for the bike microservices, which are the bike that are booked, and the query, the database. On the other hand, you can see that now the rental service call many times the client service, maybe because I first query the bike, I saw which are the clients that rent the bike, and after I call each time the client service for get the client information. Not good implementation. So it is exactly the purpose of observability. You can see what our application is doing. So if we use a better implementation, this one, and we go back and query again. Okay, now it's much better. Just one call to bike microservices, and just one call for client microservices. And you can see that now we have improved our application. As you can see, it's easier. OpenTelemetry provides support for Spring Boot application out of the box, so you don't have to do anything.
But also Java Enterprise, it can modify Tomcat or Jetty and intercept requests to servlets. So as I said, there is a GitHub project which is called OpenTelemetry Instrumentation, and there you find a list of all the components that are automatically instrumented. It's really a lot of them. So there is a very good chance that big part of your application would be automatically observable if just you switched on OpenTelemetry on the command line.
So basically, OpenTelemetry is able to instrument your controller out of the box, is REST, which are the REST services in Spring Boot naming convention. Okay. And yes, and out of the box also is take care to intercept the repository controller. But as you can see, it actually does not intercept everything, because there are a lot of classes in your application, so you have to declare if you want something more, you have to declare in some way what you want to intercept.
Yeah. Let me give you an example. So say that between two calls, or before leaving, when you leave one framework and you call another one, in between there is a lot of logic that you wrote that takes time. This will not show up here. It will show up as a blank in the trace, because it's not instrumented code, and you will not know exactly. You know that some code is there that is taking time, but you don't know exactly which piece of code. You know it's yours because it's not instrumented automatically, because it's code not belonging to a component that OpenTelemetry knows, and that OpenTelemetry would be able to automatically instrument for you. But OpenTelemetry gives you a chance to add annotations to your code.
Okay, just to give you a clue about what we are saying, this is the REST controller. If we go back, we can see that the REST controller has been intercepted. Okay, but the REST controller This one, list, no, sorry.
Direttamente su GitHub.
Yes, a moment. And the REST controller is calling the bike list bucket, but we cannot see that there is our business service intercepted. Okay, we just go from the controller to the bike repository. If you want to intercept the business service, you just add a dependencies in your application and annotated your service with this annotation, with span, and that's all.
That's all. Just a tiny dependency toward the OpenTelemetry annotations, and you use your annotations in the code, and that's it. At that point, you will be able not only to, of course, this requires code changes, but 90–80% of your application is automatically observable by just switching it on, because you are using really a lot of open source.
And this dependency contain just this annotation, so it is...
Yeah, very, very tiny. So even when you're using a backend, for example, Elasticsearch, if you're using Elasticsearch, the Elasticsearch driver internally uses Apache HTTP client, which is known to OpenTelemetry. So your call to Elasticsearch are automatically instrumented in this way, and you can see how much time is spent there. If you don't use Hibernate, it will work with JDBC as well. So it knows all the Java specification layers and the most popular libraries, and it does everything for you. And I think we are done.
Yes.
Yes. So a few minutes for questions, if any.
I have, if no one else has, but I could talk about tracing for hours.
Yeah.
If you look there, I find there's something very interesting. You can tell where the time is spent, and that your time is not very much spent in the transaction commit.
Mm-hmm.
It's mostly spent in find repository, find all by ID, right?
Mm-hmm.
Now, with OpenTelemetry, is there a way to drill down into that? Because that's your dominator right there.
Well, I understand.
A bit of a question.
Sorry. Yeah, sure. I have to repeat first. Right. So the question is, most of the time is spent into one function which is probably provided by JPA, I think. How do we drill down into that one, right? Well, I don't have an answer for this. Out of the box, OpenTelemetry is injecting behavior to produce telemetry data in certain places, so I don't think you can provide more. What you could do maybe is a combination of AOP, for example, in Spring, because you could define an aspect on certain method, even not yours, and either use the annotations, or there is also an OpenTelemetry API that you can use to produce the trace telemetry data. So I think you could, if there is some particular method and you have access to the source code and there are certain parts that you want to explore, you could maybe use aspect-oriented programming to drill down into some parts of the method.
Code injection, or like writing code though.
Yeah.
Okay.
Do you know other ways?
Several.
Cool.
I'm also the lead for Trace Compass, which can consume open tracing traces, but it can correlate with other traces on your system, including OS level traces.
Mm-hmm.
And with OS level traces, you can read where the file is being read, or where any files are being read.
Mm-hmm.
So that's a very powerful thing, but I was wondering how much of a market this would have for developers like you, because we cater to a very specific clientele with what we're doing, which were the local ones.
I don't think I can repeat all of this.
So basically, every operating system has instrumentation in it, pretty much.
Mm-hmm.
And because of that, you can access that and correlate it with this trace, because time is time.
Yes.
And with that, and knowing which system calls are being done, You know which files are being accessed. You know what's going on the black box level, on your application level. And that can be correlated with this with no Java code at all, also.
Okay, so the comment is that because operating systems also produce trace information about the behavior of an application, and the time is the same, you can correlate the traces producing around this time by the operating system and trace even more, right?
Yes, have more information available to the developer.
Yeah. We found this very valuable, as I said, also in product development, because when something wasn't behaving as expected, earlier we would maybe fire up a debugger or a profiler like JProfiler or your kit, and that takes time. You need to deploy the application, create same data, and so on. With this, we basically switch on OpenTelemetry on Jenkins through a parameter. We redeploy the application with OpenTelemetry enabled, or we always deploy with OpenTelemetry enabled. And when something doesn't work as expected, Zipkin or whatever you're using can help you understand where you're wasting time. So it's a huge time saver if you have to figure out why the application is slower or it's getting slower. Maybe you miss an index in the database, you check telemetry traces for the last few days, and you see that the query time is growing with the number of rows in the database, and it's full of hint. Of course, for that you could use an AWR if it was Oracle or other stuff, but it gives a lot of information in a very easy and convenient way. I think we're done, unless there are other questions, so thank you.